Now this next section is called Arithmetic Sequences. So it's just like we were saying at the end of the last video, it's a certain type of sequence. And let's see, what it basically is it's a sequence where each successive term is found by adding a constant amount to the previous term. So an arithmetic sequence, something, I don't know, just a simple example would be like 1, 4, 7, 10, on and on, because that's an arithmetic sequence because you're adding the same thing to the previous one to get to the next one. So like to get from 1 to 4, you're adding 3. To get from 4 to 7, you're adding 3. To get from 7 to 10, you're adding 3. So you can probably figure out the next term, you add 3 and you get 13, you know, and on and on. So that's pretty much what an arithmetic sequence is. It's each successive term can be found by adding a constant, which actually in this section has a special name. They call it the common difference. To the previous term. And then we'll have a nice formula for how to get the general term for these guys, because they're not easy, or not, you know, yeah, they're not super easy to come up with it on our own. So that's actually what they start off with right away. Arithmetic sequence. Here's the formula to find the general term. Let's see. We got, it says an arithmetic sequence has a common difference. Like we're kind of talking about that. That's the thing that you're adding to each term to get to the next one. So the formula for the nth term is, and here's the general term formula. Let's see. Where this guy, the a right here, a is your first term. So if you want, you can actually write it as a sub 1, because that's what we've been calling it in the previous section. A sub 1 is your first term. D is your common difference. So if you just replace D for common difference, whatever it happens to be, like in the above example we wrote, the common difference was 3. The first term, replace it with the actual number, and then you should have the general term at that point. So we'll practice some of that, but first, just to get kind of a feel for it, let's answer these true or false questions, just to make sure we really understand what these things are. Okay, it says true or false. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. Yeah, that should be, because you know the first example we looked at, it was all the terms of the sequence were 3 apart. So that should be true. They should all differ by the same amount. Yeah. I think that's what they mean, right? Yes, I think by constant amount they mean that it's always the same number, you know? Like in the previous one, the common difference was 3. How about this other true or false guy? They say, in an arithmetic sequence, each term after the first term can be obtained by adding the common difference to the preceding term. That's also true. I think that's kind of the same way, or, you know, a different way to say the same thing. Let's see. Now, I think the first or the second objective here, they're just describing this sequence. We don't have to go find the general term yet. They said, write out the first 6 terms. Okay, so we want A1, A2, A3. Just kind of getting ready here. I'm not sure what I'm doing, but I'm getting ready. A5, A6. Alright, first 6 terms of the arithmetic sequence, whose first term is 100. Alright, so we're ready to just start right away. That's the first guy. And the common difference is negative 30. So that means that I can take the first term and add negative 30 to it. And that should give me the second term. Let's see, 100 plus negative 30, that should be 70. And then to get the third term, I take the previous one and add negative 30 to that. So I'll take 70 and add negative 30. 70 and negative 30 makes 40. That'll be our third term. And you can kind of see where this is going. You're pretty much, you know, instead of thinking of it as adding negative 30, you can think of it as subtracting 30. Either way. Now I'm taking 40, the previous guy, and adding negative 30. Or in other words, I'm subtracting 30, and I'm getting 10 here. Alright, now I'm going to add negative 30 again to get the fifth term, because they want the first 6 terms. So I'll add negative 30. 10 and negative 30 makes negative 20. So our fifth term must be negative 20. And then the last one we care about, the 6th term, I'm going to find by adding negative 30 to that guy. Negative 20 and negative 30 together make negative 50. There's our 6th term. So it's really all it takes to find the terms of the arithmetic sequence. You don't really need the general term. As long as you know the first term and the common difference, then you should be able to find as many terms as you want. So in this one, for example, they also want the first 6 terms. Let's get ready for them. A1, A2, A3, A4, A5, A6. They gave us the first term right off the bat. They say the first term is -7, so we'll start off with that guy. And then from there we're just adding the common difference of 4. In this case, the common difference is a positive number, so these should be going up. I'm going to add 4 to get the second term, then I'll add 4 to that to get the third term. I'll add 4 to the third term to get the fourth term. I'll add 4 to the fourth term to get the fifth term, and add 4 to the fifth term to get the sixth term, and that should do it. So second term, -7 plus 4 should be -3. If I add 4 to that, I'll get +1. +1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. So those are the first 6 terms of that sequence, that arithmetic sequence. Not too bad. Now we want to find the 9th term of the arithmetic sequence. Okay, so these ones, when they say find the 9th term, or in this next one, find the 50th term, that'd be kind of difficult to actually write those all out. Can you imagine trying to find, you start with the first term, and then you're adding the common difference until you get to the 50th one? That takes too long, so I think for these what I'd do is find the general term first. Let's see, maybe I'll kind of give a hint. Yeah, for these types, find the general term first. Find the general term first, which is, the formula they gave us, A1, that we haven't used yet, plus n minus 1 times the common difference. So do that first, then replace n with the term you want. So in this one, we want the 9th term. So I'll replace n with, n with 9. And the next one, we want the 50th term, so I'll replace n with 50. That's kind of the idea. So first things first, I'm going to get ready and find the general term here. The formula they gave me, a sub n, is a1, the first term, plus n minus 1 times the common difference. So an is, first term, what'd they say, is 6. So that guy's going here, 6 plus n minus 1. For now we're keeping n general. We don't want to replace it yet because we're wanting the general term. And then d is the common difference. They gave it to us here. They said it's 5. So -5. So there's our general term. Not that that's what they want, but that would give us the key to find any term in the future that we want, whether it be the 9th or the 50th or the 1000th or whatever. And now if we want the 9th term, which is I think what they asked for, right? Let me see. Yeah, okay. 9th term, that means I just take the general term above and I replace n with 9. So it should be a sub 9 equals 6 plus 9 minus 1 times -5. So that's 6 plus, 9 minus 1 is 8 times -5. That's 6 plus, 8 times -5 is -40. 6 and -40 make -34. So that must be our 9th term of the sequence. And then the next one, the 50th term, now I'm really glad I'm using the general term here, because I don't want to have to write out 50 things to figure it out. The formula says it's the first term plus n minus 1 times the common difference. So let's see, what did they say was the first term? No, not that. First term is 7, so that's going to go here, because that's what a sub 1 stands for. So that's 7 plus, and like we said, for now we're going to keep n general, n minus 1 times the common difference, which is 5. There we go, and that looks fine. That's the the general term. Now I should be able to find any term I want. In particular, they want the 50th term now. That means just in the box, general term I wrote above, I'm going to write a 50 for n. A sub 50 is 7 plus, instead of n, I'm going to write 50 minus 1 times 5. And once I simplify this, then I'm all done. That's the 50th term. 7 plus, let's see, 50 minus 1 is 49 times 5. Okay, looks like it's 245. 7 plus 245. 245 and 7 is 252, I believe. So there it is. Okay. Alright, interesting. Alright, looks like they're trying to give us some applications here. That's kind of interesting. It says, in 1990, 18.4% of American women aged 25 and older had graduated from college. On average, this percentage has increased by approximately 0.6 each year. So I think that, if we're trying to find an arithmetic sequence, I think that'll be your common difference, because that's how much each year it increases, which is, what's the definition of common difference, is what's being added each time to find the next term. So write a formula for the nth term of the arithmetic sequence that models the percentage of women aged 25 and older who had or will have graduated from college n years after. It looks like, since you want the first term is what percentage of women have graduated college in the oldest year, I guess, that they're talking about. Looks like it's going to be 18.4, because that was, the first percentage that we started with. 4, and then the common difference we already said was 0.6, because that's how much it's increasing per year. So write a formula for the nth term. Okay, so they're just asking for the general term now, and we can use the formula we were given: a1 plus n minus 1 times the common difference, and then just fill in what you know, and that's it. A1 was 18.4 plus n we're trying to keep it general, that way we would be able to find out the percentage in any year in the future. N is going to stay general. We're replacing A1 and D. Let's see. D is 0.6. There you go. And you might be able to simplify that a little bit, but I think for our purposes that's a good answer right there. I guess if you wanted to, you could simplify it. I'm not saying you have to, but if you did want to, what I would do is distribute this 0.6 into the parentheses here. So it'd be 18.4 plus 0.6 times n minus 1 times 0.6, that makes negative 0.6. And then you're just kind of combining like terms. I don't think this is necessary, but just in case you ever come across this. These two are like terms. 18.4 minus 0.6 is 17.8, I believe. Yeah. So that's just, I guess, an alternate version for the general term. This, what I'm boxing now, and this, they're both good answers. Both correct. Just one, I guess, looks a little simpler, and the other one's, was faster. So it kind of depends on your purposes, or I guess. And then this part 3b, they say, use the result from the previous problem to project the percentage of American women age 25 and older who will be college graduates by 2030. So I guess I got to figure out what value of n that corresponds to. Because what they say n was supposed to be, for the nth term, will have graduated from college n years after 1990. So n is the number of years after 1990. Number of years after 1990. And then I guess if you're talking about 2030, that's 40 years have passed since 1990. We're just going to replace n equals 40 in the general term. And now it's up to you, because we have two forms of that general term. I don't know. I guess the bottom one's a little simpler. We did a lot of work to simplify it. We might as well use it, huh? What do we say it was? an equals 0.6n plus 17.8. So now, like we said, we're just going to replace 40 for n, and that should, once we simplify it, that should tell us approximately the percentage of American women age 25 and older who will have graduated college. So subscript of 40, that means that n should be replaced with 40. 17.8, okay. So I believe that's 24 plus 17.8. That's going to be, let's see, 41.8. So it looks like 41.8% of women in 2030 over 25 will have graduated college. That's pretty good, huh? Okay, interesting. I wonder how accurate that is, huh? Okay. I think this is the last topic in this section. This section's pretty short. I mean, I think arithmetic sequences, they're not too complicated, They're like those people in your lives that you always rely on. They're not complicated. They don't change. They're always there for you. That's what these guys are like. They're nice and simple. They're kind of cute. But this last objective here gives us a way to calculate the sum, or the summation notation like we saw in the previous section, as long as your general term is that of a arithmetic sequence. So this is our formula here. If you want, what this represents is what, like they said in the box here, the sum of the first n terms of an arithmetic sequence can be found with the following formula, where a1 represents the first term and an represents the nth term. So it's kind of like the average of the first and the last term, and then times n, sort of. So it's kind of confusing, but I think once we see an example, it'll make more sense. This one, 4a, it says, find the sum of the first 15 terms of the arithmetic sequence 3, 6, 9, 12. Okay, so we need to know, well, what is the value of n? Well, in these types of problems, n is how many terms you want to add up. So I said find the first 15 terms. That means we want n equals 15. And then another piece of the puzzle here to use this formula is a sub 1. That's just the first term, so I'm going to grab that first term. He's 3. And then a sub n, remember we said n in this case is 15, so we want the 15th term. That's a little tougher. We have to go find that guy. So it might not be a bad idea to find the general term. Or you know what, you can use the general term. What is it? A sub n. We saw this in the previous problems. It's a1 plus n minus 1 times the common difference. But really, because all we care about is the 15th term, we don't really need to know any other terms. I can replace n with 15 right away. I'm going to replace, n is 15, because I want the 15th term. A1 we said was 3. The common difference, I guess you have to look at the sequence. What does it look like the common difference is? How do you get from 3 to 6, 6 to 9, 9 to 12? I think you're adding 3 to each one, right? So it looks like common difference is 3. I'm going to replace 3 for the common difference. 3 is actually the first term as well. N is 15. And I think we're good. A sub n is 15 equals the first term, a1, which we said was 3, plus n, which all we care about is when n is 15. So I'll put 15 minus 1 times the common difference, which is 3. So this should tell us the 15th term. 3 plus 15 minus 1 is 14 times 3. 14 times 3 is 42, I believe. Is that right? Yeah. 3 and 42 makes 45. Okay. So I think we got all the pieces to the puzzle. A15 is 45. So we should be able to take all those pieces of the puzzle and put them into our new formula. Let's see, just to show that now we're kind of calculating something new. The sum of the first 15 terms is, according to their formula, s sub n, but we want n to be 15, equals, well, I guess at first I'll put n and then I'll put 15 later, times a1 plus a15, because that's n. Well, we'll just leave it n for now. Over 2. Okay, no, fill in what we know. Let's see, s sub 15 is n, which we said we want n to be 15, times a1, the first term was 3, plus a15 was what we just found, it was 45. So 3 plus 45 is going in the parentheses there, and it's over 2. 2 is just always, that's always the case in the denominator for these guys. That's part of the formula. Looks like 15 times, let's see, 3 times 45 is 48 over 2. And that reduces a little bit. 2 goes into 48 24 times. So we're looking at 24 times 15. Which is 360. So that would be the sum of the first 15 terms of the sequence. And we didn't even, the beauty of this formula is we didn't have to find the first 15 terms to figure out what the sum of the first 15 terms is. It was a lot of work though. I think this last example here will really illustrate why this formula is nice. Because this is saying find the first 50 terms. So we'd have to take the first term and add the common difference 50 times until we get to the 50th one. And then we want to find the sum. That would be a lot of work. What we can do is just use the formula. So they want the first 50 terms. That means n is 50. This is n subscript 50, or sorry, s subscript 50, which means I should be able to use the formula that they gave me to find the sum of the first 50 terms. It's n times a1 plus an over 2. But specifically, we want n to be 50 in this case. S sub 50 is, okay, 50 times the first term. What is the first term of the sequence? You have to go find out. Let's see. A1 is, this is the general term. So a sub n, that's 6. They use an I just to confuse us, but you know, it's really an n if you're used to n. So I should be able to find the first term by just replacing n with 1 in that general term there. 6 times 1 minus 11, that's negative 5. So there's the first term. I can replace that in my formula here. Negative 5 plus a sub n. Okay, that's supposed to be the 50th term. Let me think about that. I'm going to think about that guy. Over 2. So the 50th term I can find a similar way. This one was actually easier because they gave us the general term and we didn't have to go find it. Let's see, so I should be able to find a sub 50 by replacing n equals 50 in this general term here. So take that, 6 times n, which is 50, minus 11. Replace n with 50. 6 times 50 is 300. Minus 11, that's 289. Wow, that's a big number. Oh well. So that's going to go in our formula here. And once we do that, then everything should simplify down nicely. And I think we're all done after that. Let's see here. Oh well, whatever. I'll just draw a little line. Okay, S50 is, we already had a 50 times, and then parentheses, negative 5 plus We just found the 50th term to be 289, so I'll go ahead and replace that guy. And now it's just a matter of simplifying this. So we have s sub 50, which is the sum of the first 50 terms. 50 times -5 and 289 is 284, I believe. Is that right? Yeah. Over 2. And this simplifies, let me see. 2 can, I don't know, you can reduce it with 50 or reduce it with 284. 2 goes into 284 142 times. So it just comes down to 50 times 142. And I believe that's 7,100. That's a big number. Whew. So I know that seems like a lot of work, that problem, but remember the alternative. This means I have to find the first 50 terms of the sequence. That's 50 things I have to find, and then I have to add them all together. Whereas here, as long as I know how many terms I want to add together, that's n. I want to add 50, so n is 50, and I know the first term, and I know the 50th term, then I can just plug them in this formula and I'm all done. And since in this case they gave us the general term here, inside the summation notation, it wasn't so bad. Actually, this one was a lot easier than the previous one. Sorry, that was good. I think we kind of mastered arithmetic sequences at this point. There's not a whole lot left to discover. The next section has more interesting sequences. They're called geometric sequences. And there's a little bit more to them, so they'll be more interesting, I believe.